Welcome back to the generative VQA series. In this video, we will finally train our model, but we are going to train it in feature extraction mode. This means our CLIP image encoder is frozen, GPT-2 question encoder is frozen, and only the GRU decoder and our fusion layer will learn. So this keeps the training simple, fast and stable. So in short, let me tell you what we will gonna do in this video. So first of all, we'll freeze CLIP and GPT-2. We'll build training function and where we use teacher forcing, and we will also add mixed precision training, and we're gonna save checkpoint, do some early stopping and just train it. So let's start by importing all the codes which we have already built. So first of all, we are going to import the required libraries, and here our main library is PyTorch, which we are using in all the videos to build this generative VQA. Next is our vocabulary. So for answer, we have used this custom vocab because answers are short and we don't need that much words or token for our answers. So instead of using GPT-2 tokens, I prefer to build my own, and that is much lighter because I think in our one we have around 1.6 k token, so that would be around 1600 tokens, and while GPT-2 tokenizer have around 50k, so like that's a huge difference, and that would affect when you have a 4 GB GPU. So like this is much better option. Next is our VQA data set, that is our data set pre-processing pipeline. So it basically reads the image, process the question, processes the answer, okay, and then give you the batch of image, question ID, answers, and all the things which we need. So now we'll start working on the code because these things are already built now. So we're going to build some helper function because while training we need to save the weight. So our first function would be save the weight or the checkpoint. So this is our first function to save the checkpoint. Okay, so basically it saves your model state, optimizer state, your vocab, word to index, index to word, then your special tokens, that is pad token, BOS, EOS, unknown, question max length, answer. So we basically save everything which we need during testing so that we don't need to load anything extra. This is to be sure maybe your vocab change during pre-processing when you do it during test time. So if we don't want to risk that, we're going to save everything, remember. And this would be helpful even when you want to retrain it, like continue training from that specific epoch only. Let's say you don't have that much time, you train it for 5 epoch, now we'll start again from 6, not from 1. Okay, so in that case you can use the checkpoint, like because your optimizer state is also being saved. If there's anything else which you want to save, you can also do that. That would be pretty helpful. But for now, these are all the things which I feel I should save. Next is our function to plot the losses. So this function plots training and val loss, a simple graph but very helpful to understand how well the model is learning. And next comes our main function, that is training. So let me paste the entire code, then I'll explain it to you what it does and what it does not and how it works. So first of all, this is the core training function. So now let me simplify what happens inside it. So first of all, we use cross entropy as our main loss function. So inside it we define ignore index. Okay, you remember the padding special token which we add to after every sequence in answer and also in the answers. Basically because we are working with loss, so answers is all the thing, all we need. So we need to ignore the pad token, okay, because that is not useful, that is not the main answer, that's so ignore that. And we also apply label smoothing to make training more stable. So now we loop over the entire this batch, this data loader, and each loader would give us a batch. Sorry for my stuttering, I have that, so please don't mind that. So first of all, in each training step, what do? We have few some steps. So our first step is zero the gradients. Here we do zero gradient. We make sure gradients are zero. They don't have any preset values. So we load the image, put it to our GPU. Then we have question. Again, we put it to GPU. Inside question, we have input IDs, then attention mask. Then we have answers. And these answer IDs are also put to GPU. Then next, we have the mixed precision forward. So basically, mixed precision help us to speed the training and reduce memory footprint. And it would give you the doggets. Okay. Then here we are using teacher forcing for training, and this is much better way to train instead of step by step. Okay, that would be time consuming, and also because we are using a GRU, so we would not have parallel computations. It would take time. So we use teacher forcing. This simply means we feed the correct previous token and the model predicts next token. So we shift logits and answer by one step. You see, logits and answer by one step. So here we remove the last token and here we remove the first token, because in answer we don't need BOS, and in shift logits we don't need the end of sentence EOS. And as our loss function, we reshape both the shifted logit and the shifted answers. Then at last we have this scaling function to avoid any underflow. Okay, the scaling function would be used every time you use this AMP, automatic mixed precision, I think, and basically can use float 16 in some places. I don't have full idea how it works. Just that I know we normally use float 32 precision, which takes specific space, and when you use AMP, it convert use float 16, so you take half the space. So in simple term, when you use AMP, it requires less memory, and if you have less memory or less space, then your computation would also be less, so it would take less time to train. So it basically help, and in my case it's helping a lot. Okay, so after scalar, what do? We do gradient clipping. We clip a gradient to avoid exploding gradient. So this stabilizes sequence model, and especially if you're working with RNN networks, that is GRU, LSTM, all those. In the next step, we update the optimizer, and finally we calculate the loss and give it the mean loss back. So this is our simple training function. It basically represents one epoch, that is name of the function train one epoch, as simple as that. Next is validate one epoch. So let me copy paste the entire function. It would be nearly same, just that few things are not there. Okay, so this validation loop is same but without gradient update. So here we run the model in evaluation mode. Here you can see model.eval. So it's an evaluation mode. Everything is same. You see, this is our loss function. Here we specifically say torch.no grade. So we don't want any gradient updates. Then we run a loop over data loader. Then we load the image, question, answer into the GPU. Then here we have our model. Here you can see we are not using any AMP. Okay, because we don't need to. Then again we use teacher forcing. We calculate the loss and to just see what the val loss is. So here we don't do any training, any optimization step. This is easy. Now comes our main training loop. So let me paste it. Let me paste it completely. I'll explain each thing. I don't think it would be that much. Let me paste, because this is where everything happens. Till now we have built two simple function, two main function. So first step is seeding. Seeding is one of the most important thing when you're working on really important projects such as a competition research paper, because this makes our result reproducible. So we try to seed every possible library, uh, like NumPy, PyTorch, random library, and all the thing which you can see. Next, we have paths and our hyperparameters. Basically, this is our configuration till now. So here we have paths. Okay, some paths. This is a data path, CSV path, output dir, then checkpoint, log CSV, log graph path. We create that folder if it does not exist. Okay, then we have our hyper parameter, that is batch size, learning rate, number of epoch, the patience. Okay, we'll have the, I'll tell you where we're going to use this patience. Question max length, answer max length, same normal thing which you would always use in any VQA. Okay, specifically generative VQA, because their answer max length should not be there in a discriminative VQA. Then again we load our CSV path. So here's our data set. Here we have our mini VK2, we have images, we have metadata. So this contain image ID, question ID, question, answer, and image. Okay. We are building our answer vocab. Inside it would build its vocabulary. It would have encoded decoder function. Then we split the data set into 80, 10, 10. Again, we load our VQA model. So it uses CLIP and it uses GPT-2, and we have a simple GRU and some layers in between them to fuse the image representation and the question representation. Those features we fuse them using some layers. I already explained this in another video, so please refer to the videos in the previous videos specific, they would help. Okay, then we have tokenizer and preprocessor. For CLIP, preprocessor for processing the image, and the question tokenizer to tokenize the question. And in the question tokenizer we add the pad token because it's mostly missing, so we add it. Then we create dataset for training and validation. Then we have data loaders. So now comes the training part. So here we are using Adam W. Okay, and we are using the scalar, grad scalar. Now we have defined something like best val loss. Okay, so our best val loss would be infinite. Our loss would be infinite. That could be the best possible scenario. Counter, okay, to check for something, and that something is early stopping. See here we are using counter. Then we have logs to basically log some values inside it, and those log values are basically your epoch, what is the number, train loss, val loss, and LR. Okay, we then at last save them into a CSV file. So now we also have this scheduler. Okay, then we have a loop, and that loop iterates our the times the number of epoch we have, we want to run it on. So simply we print the epoch value, what epoch it is, the current epoch. Then we call our train function and the validation function. So we have train loss, val loss. We basically print it. Now comes the early stopping. So let's say if val loss, okay, is less than best val loss. So this means our validation loss has decreased. This means there's some improvement. Initially it would be infinite, so any val loss value would be less than that. Okay, so a val loss is less, so we save. Now say this is the best val loss, and then we save the checkpoint. We sprint, checkpoint save, and counter again set to 0. And if the case is that best val loss is now greater, okay, Okay, sorry. If best val loss is less than val loss, then it would increase it by 1. And then if counter is greater than or equal to patience, it will stop. You can increase this patience, of course, like I'm using it too for my own preferences. This is my own preference. You can increase it. So we have log list. We append all the values inside it. We save the log to CSV and then a plot loss function, and we complete the training. So this is what the main basic function is. So now what I'll do, I'll run this and show you. So I've already in my PyTorch environment, and I hope it should run without any error or anything, but just that it would take a lot of time just to run it. See, for an individual epoch, it would take 2 minutes, 2.5 minutes around, and I think that's not that much. And now we can see, because what we are doing is basically training the small amount of layers, that is GRU and those fuse layers, okay, in between. That is all we are doing. So I'll actually stop it. This is just to show you. Okay, what I can do, I can pause the video and we can continue when this step is done. Okay, so here the first epoch is done and I have stopped it because I don't want to train it anymore. Okay, so this epoch basically took 2 minutes 40 seconds and 18 seconds here. So you can say an epoch took 3 minutes, and that is not too much. You can easily train it. Okay, so now assume all your 10 epochs are done. So inside you would have an output folder, and inside you would have a feature extraction folder, because that is only folder it has. So we have trained it for just a second. 10 epoch. Okay, so this is how your loss for the train loss and val loss would look. So you can see it's decreasing, because now we are only training few layers, because most of our that is CLIP and our this GPT-2 is not training. So it would be easy, and the time taken is also less because of that only, because they are frozen. We are in feature extraction mode. Okay, and I'll show you the train logs also. You can see the epoch, train loss, val loss, and LR. So you can see the training loss initially is 4.48 and it goes up to 3.15, near around the value of pi. And val loss start with 3.47 and it goes to 2.27. And learning race is initially 0.0. What is this? Maybe it would restart or do. Oh, because maybe it's the last epoch. Maybe something is with a scheduler. I don't know what is inside it. Okay. So like this is the training part. So congratulations. You have now trained your generative VK model in feature extraction mode. So where we keep the CLIP and GPT-2 frozen and only the GRU decoder learns to generate the answer. So in the next video, we'll do some testing on it, how well this model is performing. We will do some prediction. So that's all. Thank you. Have a nice day. Also, if you learned something, then please like, share and subscribe the channel for more such informative video. Now, thank you. Have a nice day.